Okay, so we'll pick up where we left off. We finished parts A and part B. And in C, we're asked, is the lake safe when the number of gallons of pollutant is at its minimum? So obviously after that point, the amount of pollutant is going to increase. We want to know if the lake was ever safe. And how are we going to do that? We're just going to evaluate P of T at time t equals 30.174. And so I say if P of 30.174 is less than 40, then the lake is safe at that point. Now, how are we going to determine whether P of 30.174 is actually less than 40 or not? We only have the derivative. However, note that we're working with two values of P. We have P of 0 is equal to 50, which is information that we're given at the beginning of the problem. So this is a big clue that first of all, we have a derivative, and we're working with two values of the original function. So I'm going to use the fundamental theorem of calculus to write an expression now, and that would be the integral from 0 to 30.174 of p prime of t dt. By definition, that should be the antiderivative of p prime, which is p, minus the antiderivative evaluated at 0. And so from this expression, we can use our calculator to find out what the integral of p prime of t dt is from 0 to 30.174, and we know what p of 0 is, so the only thing we're trying to solve for here is P of 30.174, and we can do that by rewriting this expression in this way. P of 30.174 is equal to P of 0 plus the integral from 30.174 of P prime of t dt. Now that makes sense. We're starting at 50 gallons, and by looking at the graph of the derivative there, we can see that the derivative is negative up to 30.174, which means that the pollution is decreasing. How much will the pollution decrease? Well, that will be determined by the area under the curve, or between the curve and the x-axis, from 0 to 30.174, and it's going to turn out to be a negative quantity because it's below the x-axis. So we're going to wind up subtracting a certain amount from 50 and seeing what we get. So let's go ahead and find that integral now. Second, calc integral option 7 from 0 to 30.174, and we get a value of negative 14.899. And so you can see from that it is going to definitely come out to be less than 40. The actual amount at that point is 35.101. So I'm going to put the calculator away and finish the explanation. And I simply conclude that the lake is safe at t equals 30.174. Now finally, we're asked, an investigator uses the tangent line approximation to P of t. I think we'll continue this in the next video so that we'll have time to complete the whole thing there. We'll stop this one here.